Hey folks, this lesson is binomial distribution. Bi means two, you guys. Let's go back real quick to the board problem right there. There's our board problem. So evaluate 8C5, and then if a coin is tossed 4 times, what's the probability of getting at least, I should say one tail, not on tail, should say one tail. So let me fix that real quick. So get at least one tail. Okay, and then the probability is going to be 1 minus of getting all heads, because if you're getting at least one tail is the opposite of getting no tails, and getting no tails would be 4 heads right there. So it's going to be 1 minus the probability of that, and 1 minus the probability of that is going to be 4 heads. Sorry, brain freeze right there. 4 heads, you guys, is a head is a head is a head is a head. 1/2 times 1/2 times 1/2 times 1/2 is 1/16. So 1 minus 1/16 is 15/16. Okay, and then 8C5 is 56 right there. Okay, all right, so my kids asked for number 40, so that's what that was right there. So here's our binomial distribution. Okay, you got a random variable is a variable whose value is determined by the outcome of a random event. And you're thinking, what? Well, here, for example, rolling a 6-sided die, our random variable can be x, and where x is all the possible outcomes, 1, 2, 3, 4, 5, or 6. So a probability distribution is just a function that gives the probability of each value of the random variable. So what's the probability of rolling a 1, the probability of rolling a 2, a 3, a 4, a 5, or a 6? So that all of these probabilities will always add up to 1. So the probability distribution. So we can get a 1, 2, 3, 4, 5, 6, and each probability is 1/6 right there. Okay, and all of these add up to 1 right there. Okay, so there's a probability distribution. So let x be a random variable that represents the sum of 2 6-sided dice when they're rolled. So let's make a table and a histogram showing the probability distribution. Okay, so here's our rolling 6-sided dice. So we can get a 1 and a 1. So we want to know the sum. So we can get a sum of a 2, a 3, a 4, a 5, a 6, or even a 7 right there. Here we can get a 3, a 4, a 5, a 6, a 7, or an 8. Can you see they're going up? This is going 4 through 9. This one's going 5 through 10, and so on. So we can get sums of 2 all the way up to 12 right there. So those are the numbers that we're focusing on, is the sum right there, okay? So the sums are 2 through 12 right there, and the outcomes are how many times do we see a sum of 2? I only see a sum of 2 once. I see a sum of 3 2 times, these 2 times. I see a sum of 4 3 times, so and so on. So those are all the different ways we can get the sums of those numbers. Okay, there's 36 different ways right here. So the probability of rolling 2 dice and getting a sum of 2 is 1 out of 36. Okay, when I click, all these are going to fill in right there. So you're going to see some different fractions right there. So probability of getting a sum of a 2 is this 1 time out of 36 times. So that's where 1/36 came from. Okay, how come this says 1/18th? Well, that's the reduced fraction of 2/36. Okay, so here's 2 times we can get a 3 out of the 36 different times right here. There's 36 possibilities. So 2 out of 36, 2 over 36 is 1/18th. 3 over 36, here it is right here, 3 over 36. 3 over 36 reduces to 1/12. 4 over 36 reduces to 1/9. 5 over 36, here's 6 over 36, and so on. So that's where we're getting those. Okay, so it says make a table. Now we're going to make a histogram. A histogram is a fancy name for a bar graph, and where the bars are squished together. Okay, so down here are going to be the sums, 2 through 12, and over here is going to be the probability. So this will be 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6 right there. Okay, so there they are right there. So here's 2 6 is 1/18th. Here's 3 6 is 1/12th. 4 6, 5 6, and 6 6 is 1/6. Okay, and we're just going to put, okay, where this bar is going to go up to 1/36. Okay, so we're going to make a bar right there, and then we're going to connect that bar to 1/18th. So this bar is going up to 1/18th right there. Okay, and so on and so on. Okay, all right. See how that's nice and symmetrical right there? That happens a lot in nature, and so anyway, so we can use this graph to answer these questions. So use the probability distribution to answer these. What's the most likely sum when rolling a 2 6-sided die? Okay, which one is it? Well, it was the most likely sum was 7 right there. Okay, so it's that bar. What is the probability that the sum of the 2 dice is at least 10? So we're going to take this one, and this one. That's at least 10. The sum is at least 10. So we add all of those fractions up and we get 6 out of 36, which is 1/6. Okay, in a binomial distribution, there are n independent trials. Remember, bi means 2. So each trial only has 2, that's why it's bi, 2 possible outcomes, whether it's success or failure, or on or off, or left or right, or male or female. And they don't have to be 50-50. In fact, most of the times they're not. It could be 40-60 or 30-70, but they have to add up to 100% no matter what. Okay, so the probability of success is the same for each trial. That's the other thing that has to be. These are the rules for binomial distribution. So it has to be the same all the way through. So the probability is p. So the probability of the failure is going to be the complement of that. So it's going to be 1 minus p from 100% minus that. So for a binomial experiment, the probability of exactly k successes and n trials is given by this formula. Okay, so nck. So this p is our probability of success to the k power, to this power right here, and then this is the probability of failure. Some books call this q right here. Q is just 1 minus p. Okay, so this would be 1 minus p right there, and this is to the n minus k trial right here. Let's try one of these, you guys. So here we go. According to a survey, about 41% of U.S. households have a soccer ball. So this is p right here. So q is 1 minus this, so 59%. So suppose we ask 6 randomly chosen U.S. households whether they have a soccer ball. So we're going to draw a histogram of the binomial distribution. So we got to find each probability of each event. Okay, so in this case, P is 41% or 0.41 and N is 6. Okay, so we need to calculate the probabilities. If we're going to do a histogram on this, we need to find each probability that of the 6 randomly chosen households, none of them had a soccer ball, or what's the probability that one of them did, the probability that 2 did, 3 did, 4 did, 5 did, 6 did. Okay, so, and it could change if you picked a different 6 houses and a different 6 houses, but these are the probabilities right here. Okay, so we're going to use that formula on each one right here. So nck, p to the k, 1 minus p to the n minus k power. Okay, this isn't as hard as it looks. One of my kids were kind of grumbling today, and I told them to take off their worry hats. This is an easy chapter. It's just number crunching here. Okay, so the probability that there's no households that have a soccer ball in it. So we're going to go 6C0, the 0.41 to the k power, and then 0.59 to the n minus k power. So 6 minus 0 right there. So it's number crunching. You just plug it in right there and you get 0.042. Okay, so we get to do that for the other 6 scenarios right there. And then we're going to make a histogram with this. Okay, so we're going to plug them into all those formulas, and we did that already, and so here they are right there. Okay, so we're going to make a probability histogram with these probabilities going up on the right hand column. Okay, these are going down on the bottom row right there. Okay, all right, so when you're making any kind of graph, your first column is always your x-axis, your second column is always your y-axis. If they give you it in a table like this, the top would be your x and the bottom would be your y. Think of alphabetical order, x comma y. Okay, so this is my x-axis, this is my y-axis, and right here is the origin. So we're in just quadrant 1. Okay, so this would be like the y-axis right here. Okay, and I put these numbers right here. They are going to hold all of these numbers. So as long as these numbers will represent these, we are good. And I'm going up by 10%. So this would be 5%, 0.05. This would be 15%, 0.15. 25%. Okay, and so here's the number of households that have the soccer ball, and here's the probabilities over here. So here, if this is 0.05, then 0.04 is going to go up just a little bit below that right there, and then 17%, well, here's 15%, so 17.6% is going to go a little bit right here. So one household is going to have a probability of 17.6%, and so on right there, okay? So there would be our probability distribution, and here's that half of a percent right there. The 0.005 is 0.5%. Remember, change it to a decimal, move it 2 places to the right. Okay, so it's barely going up right there. Okay, so we can answer these questions. What's the most likely outcome in the survey, and what is the probability that at most 2 households have a soccer ball? Okay, so at most 2 households would be these numbers right here, this one plus this one plus this one right here, okay? And then 2 households is the one that has the bar that goes up the most. All right, you guys, if you are in my class, that would be your homework assignment. Take care.